go. Alright, we've been talking about right triangles. And so let's draw like a nice little right triangle here. And let's do just a quick little review of what we've been doing the last day. Or two. Or just one, I guess. Was yesterday the first time we started talking about this? I think it was. Alright, so there's a nice right triangle. And I did this in the other class. I'll do it in here as well. Here's something you probably won't see in the geometry book, but I'll refer to it every once in a while. You'll see this in Algebra 2 quite a bit and beyond, all right? And instead of calling, remember yesterday we called this angle A, we called this B, we called this C. A lot of times they're going to do this. They're going to give this unknown angle, the one that you want to solve for, they're going to give it a specific letter. But the letter is not just a regular letter of our alphabet. It's actually a letter in the Greek alphabet, right? And for some reason, mathematicians love to use Greek letters. Okay, they probably because the Greeks came up with a lot of the math. Is probably the reason. But the this angle right here, we use a Greek letter of the alphabet, and it kind of looks like this. Kind of looks like a O with a little swooshy thing through it. Somebody said that looks like the Orioles O. You ever see the Orioles O on their hat? Kind of looks like that a little bit. May not look exactly like that in the book. When when you have it in print, it looks, I don't know, I think they usually maybe look like that or something, but I always put a little swoosh through it. Just looks a little cooler. It's a Greek letter of the alphabet. It's an actual letter, like A, B, C, D, E, F, G. It's just a regular letter in the Greek alphabet, and it's called theta, T-H-E-T-A. We don't say theta or theta, we say theta. That's how I've always... Yep, in the Greek alphabet, that little symbol right there is a Greek letter, and it's called theta. So if you were going to read something in Greek, I think, and I believe it's a capital theta as well, I believe. I'm not really sure what a lowercase theta would look like, but I'm pretty sure that that's a capital theta. And we use that all the time just to describe an unknown angle. And I could have called an angle A. I could have called an angle B or C or D or F, whatever. But a lot of times, you'll see this a whole bunch, the further in math that you get. An unknown angle, they'll use the letter theta, the Greek letter theta, for that unknown angle. Okay? So, I'm actually not going to use it right now, though. All right? I did a little bit in the other class, but I think I'm going to change directions just a little bit here. So every once in a while, I might do that. I'm like, okay, solve for theta, and I might put theta right here, and that means just solve for that angle. That's all it means. Okay, it's nothing real fancy. It's nothing like it's real hard to figure out. It's just an unknown angle. That's all it is. So you learned a little Greek today. How about that? All right. And you've seen those on shirts, right? Like college, right? Fraternities, sorority shirts, and they got all these Greek letters on it. You'll see that on one of the shirts as well. You'll see that theta. Let's just do this though. Let's label like we did yesterday. We'll call this ABC, just like we did yesterday. And let's just put some numbers in here. In fact, I'm just going to go 3, 4, 5 just to make this easy. And what I want us to do, this is just a little bit of a test just to see if you remember your trig functions. Do you remember the little device that we used to learn our trig functions? It's Sohcahtoa, good. So is spelled S-O-H, and the ka is C-A-H, and the toa is T-O-A. All right, Sohcahtoa. It's just a little mnemonic device. You ever hear that word, mnemonic? It starts with an M, but it's M-N, mnemonic. It's just like, it's just the first letter of the word stands, for something. So it's a mnemonic device, and it's just so we can remember what it is. So how's it, what's it good for? What's the S stand for? Sine is what? Opposite over hypotenuse. It doesn't stand for the over, it stands for opposite. And then we know that it's the opposite over the hypotenuse, even though they're next to each other. It's just how we remember it, okay? The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. And that's really going to come in handy. So they may give you a triangle like this, and they're going to say, okay, find the sine of angle A, find the cosine of angle A, and find the tangent of angle A. Because I was looking at your worksheet while you guys are coming in here, and I forgot to go over this with the other class, so I might have to hit this a little bit tomorrow with them, but you guys will see it. So the sine of angle A. So here's angle A right here. So I want to find the sine. Now I just want to write it as a fraction. They actually ask you in the worksheet to write it as a fraction and a decimal. Okay, but at first let's write it as a fraction, and then we can always put it into a decimal. It's not that big of a deal. But the one that I'm really concerned about is the fraction. So the sine, it says of angle A. So we know we're looking at this angle right here. And let's see, what is the sine? It's the opposite over the hypotenuse. So if we're at angle A, which side is the opposite side? CB, which is what? 3. That's the opposite side. And what's the hypotenuse? That one right there. Okay, so what do we write our fraction as? The sine is what? 3 over 5. Okay, that's all they're asking you for. They're not actually asking you to find the angle. We'll do that in a few minutes here. But they're just saying, what is the sine of the angle? Just so you recognize, which one's opposite, which one's hypotenuse, and you know to put those together with the sine. That's all there is to that. Pretty simple, isn't it? Let's do the next one. Let's do the cosine. So the cosine is what? Adjacent over hypotenuse. Which one of these sides is the adjacent side? 4. So that's the adjacent side. So what is the cosine then? It's adjacent, which is what? 4 over the hypotenuse, which is 5. Pretty simple, isn't it? As long as you know what those words stand for, it's pretty easy to plug them in. Let's do the tangent this time. The tangent right here is the opposite over the adjacent. So what numbers are we going to use here? 3 and 4, okay? And it has to be in that order, 3 over 4. There's the opposite. Opposite of what? Opposite of angle A. Everybody see that? So it's really important that you recognize which angle that you're working with. This is the sine of angle A, because the sine of angle A and the sine of angle C are going to be different. So you got to make sure you know which one's which.
That's the fraction part.
That's the fraction part. Now, they also say write it as a decimal, but that wouldn't be that hard. How would you write that as a decimal? Yeah, just divide. 3 divided by 5. Can you do that in your head? It's over 5. You should be able to do that. If it was over 10, what would it be? It would be 6 over 10. And what's 6/10 as a decimal? 0.6, right? Yeah, you should do that in your head. What about 4/5? Let's do 4/5 in our head without a calculator. So 4/5 is the same as what over 10? 8 over 10. So what's 8/10? 0.8, right? 8/10 is 0.8. Would you agree? I mean, you could always put it into a calculator, but it's nice to know that. 3/4. You should know 3/4 already. 0.75, right? So that's 0.75. I'm really more concerned that you write it as a fraction than the decimal. Okay, they say in the worksheet write it as a fraction and a decimal, so go ahead and do that. But I'm really more concerned about the fraction part. I think that's the most important part. Okay.
So you will sometimes get improper fractions.
Yeah, absolutely. Yep, you could get improper fractions. All right. In fact, if we did C, let's do this in a different color. Actually, before we do that, let's get rid of these words right here. We'll keep the numbers in there, and we'll get rid of that. Now, let's do the rest in a different color. Let's go yellow. So now, let's take a look at angle C. Not at angle A, but now let's look at angle C. What do you think they're going to ask you about angle C? Yeah, the same thing. Sine, cosine, and tangent of angle C. So let's do that. So let's find the sine of angle C. Let's find the cosine of angle C. And let's find the tangent of angle C. Are they going to be the same exact answers? No, because we're dealing with a different angle. So now our opposite and our adjacent are two different sides now, aren't they? So this time, what is this 4 right here to angle C? This one's opposite. Okay? What is the 3 to this angle C? It's adjacent. See, it all depends on which angle you're looking at, right? On which one's opposite, which one's adjacent. But what's the 5? 5 is still the hypotenuse because it's still opposite the right angle. So that's never going to change. It's your opposite and adjacent that could possibly change depending on which angle that you're working with. Okay? Yes, Jada? They won't do that. They won't ask for the sine, cosine, or tangent of angle B. All right? Actually, not right now. Maybe later on. It's something we probably won't even talk about in geometry. Wait till Algebra 2, and they'll do that. It was a good question, though. What would you do here? Because, look, hypotenuse is the opposite of angle B, isn't it? All right, so that messes things up a little bit. Which one's adjacent? I mean, this is adjacent, and that's adjacent, isn't it? All right, so, but we're not going to do that. They're not going to ask you the sine, cosine, or tangent of the right angle. Okay? Not yet. In Algebra 2, they will, but we're not going to do that in here. Everybody with me so far? So let's do this. Have you figured this out yet? The sine of angle C. So what's the sine? It's opposite over what? hypotenuse, which is what? 4 over 5. Look at the cosine. Still with angle C. The cosine is the adjacent over the hypotenuse. So it's adjacent, which is 3, over the hypotenuse, which is 5. So it's 3 over 5. And what's the tangent of C? The tangent of C is opposite over adjacent. So it's opposite over adjacent, 4 over 3. And look right here, Johnny. This is where you have an improper fraction. So you can have an improper fraction here, can't you? Can't you? Yep. And if you wanted, you could put this into a calculator. 4/5 is the same as 0.8. 3/5 is the same as 0.6. 4/3 is the same as what? 1 1/3 or 1.3 approximately. It keeps repeating, but we'll just leave it like that. Now, what's kind of interesting here is knowing all that stuff. I didn't know any of these angles, do I? I don't know angle A, I don't know angle C, but I can find that. That's what this trig function is good for, all right, is to find missing angles that we couldn't have found before we knew anything about the trig function. All right, if I only knew the sides of the triangle and one right angle, there's no way I could have found the other two angles unless you knew how to do this stuff. All right, and that's what we're going to do. So let's take this one right here, and let's actually solve for angle A. Actually, we'll do it with all three of them just to show you that angle A is still going to be the same. It's not going to change at all. But we can do it 3 different ways. We did a little bit of this yesterday. I think we did this yesterday. I can't remember. Maybe we did, maybe we didn't. I'm going to do it right now, though. So let's rewrite that. The sine of A is equal to 3/5. Did we do the thing where we took the inverse? We didn't do the inverse yesterday? Yeah, we did in the other class. I'm not sure why we didn't do it in here. I think we just ran out of time or something. I was probably telling a dumb story. Did I tell a dumb story yesterday? I didn't tell any dumb stories. Seems like one in my class I told a dumb story, but I don't know. All right, let's do this. It's the thing that wastes the time. What we want to do is we actually want to solve for angle A. I want to actually find what angle A is equal to. So it's not by itself yet, though, is it? I need to put it by itself. Well, what's with the A that I need to get rid of? The sine, right. Now, the sine is not a number. It's not a variable, is it? It's just a word that just represents the ratio of the opposite side to the hypotenuse. All right, so it's not really a variable. It's not like I can divide by the sine. You hear what I'm saying? I can't just divide by the sine because it's not a number. But I can do something. I can take the inverse of the sine. For instance, if you had something like this, 3x equals 12, how do we get rid of the 3 right there? We divide by 3, right? Or we do the inverse. Because what's happening? It's 3 times x, right? What's the inverse of multiplication? It's division, isn't it? So we're actually doing the inverse, aren't we, to get rid of something? Well, we're doing the same thing over here, except it's not just a regular number. But I can't take the inverse of it. I don't know if you remember this in Algebra 1 or not, but what if I said, let's do this. Does anybody remember doing anything with negative exponents? You may not have done that in Algebra 1. It's probably, you did do negative exponents? Okay. Well, there was a rule in algebra that said 4 to the negative second or first power is the same as the inverse of the function. I don't know, do you remember doing that? You flip it to the bottom and change the sign of the exponent? Yes? No? Maybe? Anyway, there it is. So what does this mean? What does this thing do to the 4? It takes the what of it? I've used that word several times already. It takes the inverse of it, right? Okay? Well, what we're going to do here is we're going to take the inverse of both sides. If I take the inverse of the sine, it cancels it out. But I also have to take the inverse sine of the other side. And this is how we write it. It looks a little weird. Yes? Oh, 14 minutes? Okay, thanks. Yeah, just yell it out if you see that. I can almost finish this. Watch. It's the inverse sine of 3/5. Okay? I'll show you how to do the inverse sine. On this calculator, now you've got 2 calculators. I might have to do the other calculator in the next lesson. But watch. Here's how I do it. I hit second function sine. See how it looks just like we wrote? Sine to the negative first. And then I put 3 divided by 5. And then I hit equals, and 36.9 is my answer. Whoops, it's a 36.9. And that's how many degrees angle A is. So angle A is 36.9 degrees. We'll do the rest of them in the next video.